Okay, now we are going with this heuristic search strategies. Previously, we were going with the blind search strategies, and blind means that during the problem definition, you don't have any extra information. And here, heuristic search strategies, the other name for this is informed search strategies. So now it means that along with the problem definition, now you will provide extra additional information also when you are designing an algorithm. So now in this type of category, you have the concept of additional information. And what is the name for that additional information? We will call that additional information heuristic function. You will call it heuristic function. And how you can represent this heuristic function in mathematics, you can represent it with this notation h of n. And what is the definition for this heuristic function, or what this heuristic function will give you the answer? It will give you the cost, estimated cost. It will give you the estimated cost of the cheapest path. If you want to find the path from one point to another point in a map, as you have seen already, and for these 2 points, if you want to find the shortest path, or if you want to find the cheapest path, then this function, heuristic function, can give you the estimated cost for that. So in other words, what is the definition for the heuristic function here? It will give us the, the cost of the cheapest path from any node n to goal. If you will consider that map of Romania, you have the goal Bucharest. From any node to Bucharest, it will give you the cheapest path. And here we are saying that if we want to reach from Arad to Bucharest, and then what would be the shortest or cheapest path from Arad to Bucharest? If you will use this function, then this function will give you the estimated cost for the cheapest path from Arad to Bucharest. This is an example. And this here and here, for this estimation, you can use the SLD function, which means straight line distance values. So you can use a straight line distance function for this problem to find the cheapest path from Arad to Bucharest. And this straight line distance function then finally give you that answer. The definition of heuristic function, here we are saying that this is our definition. But actually in the problem, what heuristic function which we are going to use in the next algorithm, which is greedy best first search algorithm, what heuristic function which we are going to use there? We are going to use this SLD function here. What is this? Let's see that. Now the algorithm is greedy best first search. What is greedy best first search? Normally, you have already heard the name of greedy algorithms. Greedy algorithm is a bigger topic in which you have many algorithms. The concept of all those algorithms is greedy. But then you have those algorithms different from each other. One of the algorithm is greedy best first search, GBFS. Here, we already said that we will use a heuristic function. And what is that heuristic function? Previously, we said that we will use a SLD function. What is that SLD? Straight line distance function. So we will use a straight line distance function here in this greedy best first search. For what purpose? To find the shortest path. To find the not shortest, cheapest path, okay? Because here for greedy best first search, shortest is not the approach. Here the approach, here the concept is different. You want to find the cheapest path. Here, what this greedy best first search will do. For example, if Arad to Bukharas, if there is a straight line, if I will draw a straight line, how you can find what is the concept? And then if I will draw the perpendicular from Srain to here, okay, this is touching here, and then Timisoara, okay, this is touching here, for example, okay, perpendicular, this is touching here. These points are touching here. What the greedy, if you want for this Arad, how many options are available? Syrind, this is one option. Maybe I have to change the color. I don't know. There are some colors here, but yes. So one option is this available, other option is this available, other option for Arad is these three options are available for Arad. Now the question is, after Arad, which node will be selected by the greedy best first search? Because this is the selection order through which every algorithm is different from each other. Huh? So greedy best first search will select that node which would be closer to the goal node. Goal node is what? Bukharest. Goal is what? Bukharest. And GBFS, it will select that node which will be more closer to the goal node. So when we are putting this perpendicular from this point up to the Bukharest, this is representing remaining distance. Huh? And then from here to here, after this point, what is the remaining distance? And then from this point for Lugoj, what is the remaining distance? I am giving you an example of remaining distance. Otherwise, how you will calculate? You can draw X and Y and then have proper values. And finally, you can have this table with the values for the SLD. For you, it is already given. For example, when you are at Arad, how much is the distance from the goal? Maximum, which is 366, maximum distance. And now for Sarind, how much is the distance from this to this? For Sarind, it is given here, 374. For Timisoara, how much? 329. And then similarly for Oradi, you will see for Oradi, it is 380. And then for Liu Goj, similarly, you can see for Liu Goj here 244. And then for Sibiu, 253. So these values that will be calculated by using that trigonometry rules, and then it will be given to you. Huh? So these straight line distance values, which are calculated through using those trigonometry rules on a map of cities of Romania, and then it is, for example, it is given to you here. So these values are the straight line distance values, which will mention that how much distance is left up to reaching the goal node. And now, again, from Arad, three options are available. Which one will be selected? For Sarind, that when you are executing the tree from Arad, you have three options. From Arad, for example, here, from Arad, what is the distance at Arad? You can see from here, 366. And in the tree or in the map, how many options are available? Three options are available, which you are seeing here. And then you will see the values from the table. Values for the CBU is what? 253. Value for the Srend is 374. And similarly, value for the other Timisoara is 329. You will write their values here. And now, which node you will select? GBFS will select which node? Which has the minimum distance left towards the goal. So here then, if you will select Sibiu, 253 kilometers are remaining. Timisoara, 290, 229 kilometers are remaining. 374 kilometers are remaining. So then which one this algorithm will select? Because it is greedy. And the approach of this greedy is it will move you more close to the goal. So it will select CBU. It will select the CBU because then only 253 kilometers are remaining for reaching at the goal. And here the distance is larger. So then it will select the value which is lowest, which means that now the distance from the final node or the end node or the Bukharas is this. After doing that, then it will see from the map how many options are available from CBU to next. From CBU to next, 4 options. Now, you will open up them here, and you will write their values by looking over here in the table. You will write their values. And now all these four and these two, these six nodes are available in the frontier. Huh? Then again, the same approach. GBFS will select which one, which will move you more closer to the goal node. And what is that? This 176, which is the minimum value, it means 176 kilometers are remaining. So it will select that Fagaras then. And then from Fagaras, what are the options next? From Fagaras, one is Sibiu, other is Bukharest, or you can say simply Bukharest. Those two options are open now. After looking over the values there, here the Bukharest has the value 0. When you are at Bukharest, distance is now 0. You have covered all the distance. So you will write their values. Now all these nodes, these 5 and to 7 nodes are in the frontier. And which one is the uh, node you have to select next? GBFS will select that node which will move to the goal more sharply as compared to others. So it will select Bukharest because it has the minimum value. And then your algorithm will check. It is a goal. If goal, it will come out of the algorithm. But here, if, but here, just have a look over here that this GBFS is giving us this path. Arad to Sibiu and then Fagaras and then Bukharas from this tree. Arad to Sibiu and then Arad to Sibiu, then Fagaras and then, then Bukharas. So this is giving us this path. If you will add up these values, maybe it will become, I think 450, maybe something like that. Huh? But this is not the cheapest path. Optimal path is optimal path is different. What is that optimal path? Optimal path is this one. Uniform cost search has given us this path. Optimal path is this one. And if you will add these values would be less than these upper green values, okay? Upper green path values. And that is what we mentioned here. That greedy best first search is giving a solution, but not optimal solution. So that's why it is not optimal. Why? Because the path from Sibiu to Fagaras and Bukharas, the path which this algorithm is giving us, it is 32 kilometers longer than the other optimal path, which I mentioned you in red. But it is always giving us those nodes which are more close towards the goal. So that's why we are calling this algorithm always greedy. And now this is the algorithm. And here, okay. Now we can run this problem over this algorithm easily. This is not a difficult one. And here BFS, we are passing problem or the graph, this graph into it. And the starting node is what? Arad. And then we are creating a priority queue. Initially it is empty. So priority queue, our name of the priority queue is PQ, and then insert start in the PQ. In the priority queue, we are putting this starting node Arad into it. And then three, then we will keep on iterating. This is a loop. This step will, we will keep on iterating these all statements until the priority queue is empty. So if we have something in priority queue, we will keep on doing repetition again and again. And when the priority queue will be finished or when it will be empty, then we will come out of this loop. And initially, we have only the starting node in the PQ. For example, here, yes, here, I am writing that PQ has the value what? PQ has the value Arad. For example, PQ has the value Arad. And then here, when we were inserting start, at that time PQ has Arad. And here priority queue dot delete minimum. Delete minimum. So what Arad has the value 366. Arad has the value 366. So I don't have any other value. So when we are deleting minimum, I have only one. So I will delete that one. I have only one value. So I will delete that one. That will come here. The Arad will come into the U. And that Arad is a goal? No. Then I will come into this else portion and this loop will execute for each action. This is action basically. For each neighbor V of U. How many neighbors? Arad has 3 neighbors. Or Arad has 3 actions. Whatever you want to say. First take the surrend. Okay. And then check surrend is unvisited. Yes. Surrend. We don't have mentioned that surrend is unvisited. Yes, it is unvisited. We have not visited that node before. Then mark it visited. Okay. And add it into the PQ. So I am here adding. And I am marking it visited. And what is the value for this surrend? The value for this surrend is 374. Huh? And then, okay, I am writing it like 374 for easy comparison. And then what is the next? What, the CBU? CBU. Okay, unvisited, yes, unvisited. Mark it visited and insert it. And then I am writing CBU here, mark it visited. And what is the value for the CBU? 253. 253. And then what is the next action? Timisoara. So it is visited. If it is unvisited, yes, unvisited. Mark it visited and insert it here. This is Timisoara. I am marking it visited and inserting it. And Timisoara has what value? 329. Loop is finished. And then mark U examined. My U was Arad. Okay, my U was Arad. So I am writing that this is examined. Even I have removed it already, but I am writing it examined. You can also write something else here, something else here. If we unvisited or examined, or I don't want to write the whole name. Whole it is ex mean examined, huh? This unvisited or examined, this will work like yeah, it will work like let's see what will happen. It will work like explode set, huh? That you have already in the previous algorithm. Now this Arad is examined. Okay, this loop will end, and this we will go again to this loop. And then priority queue is empty. No, it is not empty. We have 3 elements there. Delete minimum. And here we have 374, 253, 3. Which one is the smallest? 253 is the smallest. This would delete minimum. So this would be deleted from the PQ. And now CBO is U. And here we are saying CBO is goal. No, it is not. We will come here. And what are the actions available? Are neighbors available for the CBU? For CBU, again, four actions. Again, four actions. Four actions would be available. And then Arad is visited or examined. If Arad unvisited or examined, Arad is examined. So, okay, if Arad is examined, condition if V is unvisited, it is written here unvisited. I am saying Arad is unvisited or examined. It is examined. If it is, then what? It is not it is visited. And what I should have to write here? This Arad is unvisited. Okay, we don't have anything written here unvisited or examined. Condition true. Or we can say, I don't want to insert it into the PQ again. So then what can I write? So is this okay or not? So there is no need actually. If we unvisited, so my Arad unvisited, yes, unvisited. Or examined, why unvisited? Because I have not mentioned him. Otherwise, I already visited it already. We started our problem from here. Or if you want to consider if unvisited, okay, visited and inserted, you can start it again. If you will do it, what will happen? It will not be selected because the distance is maximum here. Arad 360 here. Because the distance is maximum. So if I will write, okay, mark V. So I am marking it with V and then 366. If you will continue, okay, write it again. And what is next? Fagaras. Okay, I am writing it here now. Next action, next neighbor is Fagaras. What is the value for the Fagaras here? 176. And I am marking it with V. What is the next action? Ora D for suppose. And then Ora D, what is the value for the Ora D? 380. And I am marking it V. And then we have another action. What is that one? RV. What is the value for that? 193. And it is visited. I am doing this for all of this loop 4 times. And then U examined. What is my U? CBU is my U. I can write it. You can, okay, you can use ER simply V. Because we are not removing them or whatever. If I want to mention it E, okay, I can mention it that it is E. And then, okay, loop is finished and then I will be here. Priority queue empty? No, we have many things here. Delete the minimum. So then from the remaining 329, 66, 380, 193, what is the minimum? This is the minimum. Fagaras. And when Fagaras, you will select that, you will add further these things, and then after that you will come here. When Bukharas will be here, for example, when Bukharas will be here, the value would be 0. Next time, this would be selected. When you will pop it up from here, it would be selected. And that Bukharas would be goal, and then exit, you will come out of this algorithm. You will come out. So it's a simple. It's not difficult. The only thing is this straight line distance values are mentioned and you are expanding according to that. Here you can use this GBFS in any type of path finding. It can be navigation or it can be any other. You can use it for the puzzles. You can use it for the robot navigation. It is again pathfinding. Robot will find the path, huh? Or if there are some problem which have multiple solutions and you want to find the optimal solution, you can also use it for that by fixing some heuristic function for that. And these are the four things. If this GBF is optimal, no, it is not optimal. You have seen in our example that it was not giving us that optimal solution. Huh? Here, this is the optimal path, but it is giving us this one. So how it is optimal? So this is not optimal. So because it was not giving us optimal solution. Complete. It is complete or not? It is not complete. Because, for example, if you want to go from Lasi to Fagalas and there is a straight line here, and then you have a different table, not this one. Okay, this is for Arad to Bukharas. And if you want to go, your starting state is Lasi, and this Fagaras is your final state. And if you will draw the line something like that here, if you will calculate these values, and if you will start your search here, what are the actions? Two actions, Neemt and Vasloi. GBFS will give you what? It will give you Neemt because it is more close to the goal. And then it will reach there. And from Neemt, what would be the next state which will be expanded? It will be Lasi. And from Lasi again, when it will be selected, GBFS will give what? Neemt. And then you will be here. Like a loop, huh? This is only one example to negate this theory that it is not complete, huh? So is it complete? No, it is not complete. And time complexity order of B raised power m. M is the maximum depth of the state space. Because we don't know, it is not depth first search that we will go in on the leftmost side, or it is not breadth first search that we will go like in breadths, huh? Or not depth that we will go in the depths, huh? So this is greedy BFS. It is going according to the cost or the distance function, straight line distance function values. It is going according to that. So we don't know in which direction this will go. So that's why it will go up to the maximum. What is the worst case? Worst case is when your solution is not not available in the state space. Then what? This will go up to the maximum depth of the state space. So which is mentioned here. And for the space, also the same. It will keep all the nodes in the memory. And we will start the next topic, A star search from here, inshallah.